Good morning, student. This is the lecture 2 on magnetism. Yesterday we are talking about magnetic field lines. This is the representation of the activity. How does a magnetic compass changes its direction when it passes from north to south? We does an activity. Take a small compass and a bar magnet. Place the magnet on a white sheet placed on a drawing board using some adhesive material. Place the compass near the north pole of the magnet. The south pole of the needle points towards the north pole. The north pole of the compass is directed away from the north pole of the magnet because similar poles repel each other. Unlike poles attract each other. Move the needle to a new position such that its south pole occupies the position of previously occupied by its north pole. In this way, proceed stepwise till you reach the south pole as shown in the figure. Just points marked on the paper by a smooth curve. This curve represents a field line. Repeat the procedure, you will get a pattern. These lines represents the magnetic field around a magnet, and these lines are called as magnetic field lines. Just see in the diagram the magnetic field lines. Both the diagrams are representing the magnetic field lines. This is very important question in terms of your board exam. What do you mean by magnetic field lines? Or give properties of magnetic field lines. Or they may ask you a question about any of the property of magnetic field lines. For that, we'll read what is magnetic field lines. Magnetic field lines are the path around a magnet along which the north pole of the magnetic compass needle tends to move. Properties of magnetic field lines. They are vector quantities which has both direction and magnitude. These magnetic field line started from north pole and ends at south pole. Inside the magnet, the direction of magnetic field lines are from south to north pole. The strength of the magnetic field lines are shown by the degree of closeness. This means that more the magnetic field lines, more is the force, more is the strength. See at the corners, the strength is more, and the horizontal part, the strength is less. The magnetic field lines are closer at the pole. Very important property of magnetic field lines is they do not intersect with each other. The reason for this property is if it does so, at the point of intersection, the compass needle would show 2 points of direction, which is impossible. Next activity about the magnetic field is how do you represent the shape of magnetic field around a straight current carrying conductor? To draw that shape, we perform an activity. For that activity, take a battery, a variable resistor, an emitter, a plug key, a long straight thick copper wire. Insert the thick copper wire through the center to the normal of the plane of rectangular cardboard. see in this figure, the right side, it is the placement or the arrangement of this activity. Here, point K is representing the key, battery is represented as positive and negative, A is representing emitter, variable resistor is represented an arrow, black color is represented the board, copper wire is representing by the brown color, and yellow color point P is representing the compass needle. We perform the activity. Connect the copper wire vertically between X and Y. Sprinkle some iron filling. Tap the cardboard. You must observe concentric circles. These concentric circles represent the magnetic field lines. Now see here to the left of this slide, I had tried to explain. The hand is the straight conductor, where green color is representing the magnetic field, the board is representing the board, and the concentric circles are representing the position of iron filling. With this, you have 3 questions in your NCERT book. Question 1 is, draw the magnetic field lines around a bar magnet. You have to draw this diagram, the right side diagram from active magnetic field lines. Second question is, give the properties of magnetic field lines. Here you have to write any of these 5 properties. You are not supposed to write full lines. You can write magnetic field lines are path around a magnet. Magnetic field lines are vector quantity. Magnetic field line started from North Pole and ends at South Pole. Magnetic field line direction is from south to north inside the magnet. Next point, the degree of closeness explains the relative strength. Magnetic field lines are closed paths, and magnetic field lines do not intersect each other. This is the answer for your second question. Third question is, why don't 2 magnetic field lines of force intersect each other? The answer to that question is, 2 magnetic field lines of force do not intersect each other because at the point of intersection we had 2 directions, which is impossible.